Physics students, good afternoon. Mr. Fugit here. Today in this video, we're going to be looking at a few of the problems from your review over test number 1, which covered over units 0 and units 1. Specifically, we're going to be looking at the last 3 to 4 problems on your review, which cover over some principles of vectors and trigonometry. So we'll first start by looking at question 17. As a reminder, copies of your review are located on Canvas in the Unit 0 and Unit 1 page. There's also a key for those problems there as well. So problem 17 says this: find the missing sides of the following triangle. And we're given something that looks like this. So Q, P is equal to 8.66, R, okay, so we're given a triangle, specifically a right triangle, which means we can use our trig functions as well as using a Pythagorean theorem. And we're also given one side of that triangle, we can call that the base or side P. We're also given the angle. So here we want to find the two missing sides of our triangle. Typically, in order to do that, we're probably going to need to use a trig function. We're going to write out our abbreviations, so COTOA, so that we can really identify which trig function best applies to solving for the missing side we want. So we'll just jump in. Let's start with Q. It doesn't matter where we start, but let's just say we want to find Q. Now Q, relative to our angle, is opposite of our angle, and we know the adjacent side, which is side P. So opposite and adjacent is going to tell us we're going to use a tangent function. So we'll plug in some values. We'll say tangent of our angle theta. Remember, tangent of theta is opposite over adjacent. So, we know our angle here is 30 degrees. The side opposite of that angle is side Q, which we don't know what that is, so we're just going to call it Q, divided by our adjacent side, which is side P, which we know is 8.66. So, pretty straightforward here. We just want to solve for the variable Q. So we'll multiply 8.66 up to our numerator. We must mirror that on the other side of our equation. So 8.66 divided by 8.66 should give us an expression for Q. Q is 8.66 multiplied by a tangent of 30 degrees. And now we can simply plug this value into our calculator. Now we do want to make sure we're in degree mode and not radian mode. Otherwise, our equation will not process the values in the way that we want them to. So we should end up getting a value for Q that is approximately right about 5. And so it should be about 4.99. We can round that up to a value of 5. Okay, so we'll check what we're looking for. Okay, so now if I come back to my picture, I know that side Q is 5. I'm going to go ahead and label that in here. Now, once I have two sides of a right triangle and I want to find the third, there are really a lot of options we can go with. We could use the Pythagorean theorem, we could use a trig function, and we can actually use several different trig functions depending on what we want to use. I'm going to go ahead and use side P again. The reason why is that, let's say I were to solve this, and I were to solve for side Q, but I were to solve for that incorrectly. And then I were to use that with a different trig function, or possibly with the Pythagorean theorem. So if I do make a mistake, well, that mistake is going to carry its way through so that I'm then going to make another mistake. So one way to minimize that is use the numbers that you're given. If I use the 8.66 and the angle 30 degrees, I'm hopefully going to have less of a chance of making a mistake. So if I stay here, I use P, and I want to find R, that is the adjacent side and the hypotenuse, which now means we would want to use a cosine function. So we would set up an equation that looks like this. Cosine of our angle theta is equal to adjacent over the hypotenuse sides of our triangle. So our angle here, theta, is 30 degrees. The adjacent side was, that was side P, I believe. Adjacent is the side touching our angle, that's not the hypotenuse. So 8.66 over h, the hypotenuse, which is side R. Okay, so we want to get r by itself, so we need to multiply r up to the numerator on both sides of our equation. those will go away. We'll be left with, on the right-hand side, just 8.66. And then to get r by itself, we now need to, as you can see, divide by cosine 30. Okay? That is an entire value, cosine 30, that we need to take to the other side of our equation. So cosine 30 divided by cosine 30, those values cancel out to 1. So we end up having r is equal to this value over here, 8.66, divided by cosine 30. So we'll plug this in, again staying in degree mode. And we should get a value, looks like about 9.99. So we can likely round that to 10 pretty safely. So now we're simply just using the angle and the one side that we were given, along with a few trig functions, to figure out the missing information in our triangle. And as we will see going forward, sometimes our triangles will be made up of things that are displacements, so things in meters. Sometimes they will be velocities, things in meters per second squared when we get to kinematics and motion. Sometimes our values for a triangle might be in units of newtons. But the ideas that we learned here for dealing with forces, for dealing with vectors, will carry us through a lot of different units throughout the year. Okay, so now we're going to jump forward to problem number 18. It says this: find the x and y components of the following vector. This is problem 18. So our vector looks like this. V equals 25 meters per second. And here we're given an angle of 40 degrees. Okay? So all we're going to do here is to find the components, which just mean the sides. So this would be the x component, and this would be the y component. We want to find what are those components. We should be able to tell that they're both probably going to be less than 25 meters per second, because the hypotenuse will always be our longest side of a triangle, or of a right triangle, excuse me. So, in order to figure out, let's say the x side, well, remember our trig functions. So, ka, tawa. So here I want to find the x side, which next to my angle is going to be adjacent. 25 is my hypotenuse. So adjacent hypotenuse, we're probably going to go with cosine to find the x component. So we'll set something up like this. Cosine of our angle, so cosine of 40, is equal to the adjacent side, A, divided by the hypotenuse side, H. So that would be, well, the hypotenuse, we already know is 25 meters per second. So to find x, our x component, we're just going to multiply by our value, 25 meters per second, 25 meters per second. So 25 divided by 25, those units will cancel out down to 1, or those values will cancel out. And now we'll have an expression for our x component. 25 meters per second multiplied by cosine of 40 degrees. Now the reason I left the units in here is to help us see this. Once we plug our angle into a trig function, there is no longer a unit associated with it. We're just going to get a numerical value. And we're going to take some value with no units, multiplied by a value that has units, meters per second. So now we're going to get out units that are in meters per second as well. So we'll have 25 cosine 40. Let's make sure that we're in degree mode here. And we should get a value of approximately 19.2. So now, here's how we can write this. Our x component, we could also write this as velocity sub x, our velocity in the x direction, is equal to, it's about 19.15. We can round this to 3 significant figures. That's 19.2. Okay, so all we did here is the same idea as before. Don't let the fact that the units are different or that there are units here throw you off. The principle is the same. All we're doing is saying that rather than having a random hypotenuse with who knows what units, we have units of meters per second. The values are representing velocities, or how fast things are moving. So now we're going to do the same thing, except for looking at a different side. For the x component, we found to be 19.2. Now the y component, that is opposite of our angle, and we want to use the hypotenuse again. And just in case we maybe made a mistake on the x component, let's go ahead and use the hypotenuse because that was given to us. So opposite and hypotenuse, that would mean we're going to use the sine function. Okay? You could also tell that we could use tangent to work between x and y. We could even use Pythagorean theorem here. There are a lot of approaches. I'm not going to dictate which one we use, as long as we're able to solve it at least one way correctly. So let's say we want to use the sine function. So we would set up an expression like this. Sine of our angle, 40 degrees, is equal to the side opposite. So opposite of our angle here is the y component, divided by the hypotenuse, which is 25 meters per second. So just like above, we have to get the y component by itself. So multiply by 25 meters per second. Multiply by 25 meters per second. Remember, whatever we do to one side of our equation to keep things balanced, we have to do to the other. So 25 over 25, those will cancel out. Okay? And we'll have y is equal to 25 meters per second times sine of 40 degrees. So again, we'll make sure we're in degree mode here. We'll plug in 25 sine of 40. So we should get a value of approximately 16.1. So our y component, which we can also write as velocity subscript y, velocity with respect to the y direction, is 16.1 meters per second. And these are the values that we're looking for, really just finding our components here. So you'll notice problems number 17 and 18 are very similar in what they're asking us to do. Don't allow the fact that there are units here to cause you too much confusion. All we're doing is taking what we've learned with some of our different trigonometry functions and applying that to solving different dimensions of a right triangle. Hopefully this gives us some good direction on problems number 17 and 18 on your review. Good luck.